Imagine a concrete structure that looks perfectly fine from outside, but inside, a weak line is silently reducing its strength. This hidden defect is called a cold joint in concrete. Hello everyone, welcome back to We Civil Engineers. In today's video, we will understand what cold joints are, why they occur, their effects on structures, and how engineers prevent them at the site. A cold joint forms when fresh concrete is poured over concrete that has already started setting. Because proper bonding does not occur, the structure behaves like two separate layers instead of one solid unit. This creates a weak interface inside the concrete. Cold joints usually appear as visible horizontal lines or layer separations on concrete surfaces. Sometimes they look like cracks or texture differences. These joints are commonly seen in beams, slabs, retaining walls, and columns. The main causes of cold joints include delay in concrete pouring, interruption during concreting, insufficient manpower, equipment breakdown, and poor site planning. If the next concrete layer is placed too late, proper bonding becomes weak. Fresh concrete remains workable only for a limited time. Once the initial setting process starts, the earlier concrete layer loses its bonding capacity. If fresh concrete is added after this stage, a cold joint can form between the two layers. Interrupted concreting and improper layer placement are major reasons for cold joints. When concrete placement stops midway, the surface begins hardening, moisture reduces, and bonding becomes weak. This affects the monolithic behavior of the structure. Cold joints can reduce structural strength, shear resistance, and durability. They also increase the risk of cracking, leakage, and reinforcement corrosion. One major issue caused by cold joints is water seepage. The weak joint acts like a pathway for water. This becomes dangerous in basements, water tanks, retaining walls, and underground structures. A construction joint is planned intentionally with proper bonding treatment, but a cold joint forms unintentionally due to delays during concreting. Construction joints are designed safely, while cold joints are considered defects. Cold joints can be identified through visible joint lines, surface texture changes, hammer sounding, and ultrasonic testing. These methods help engineers evaluate defect severity. Cold joints can be prevented through continuous concrete pouring, proper planning, backup equipment, proper vibration, and good supervision. Proper timing during concreting is extremely important. If delay becomes unavoidable, the old concrete surface must be prepared properly before restarting concreting. This includes roughening the surface, cleaning loose particles, and applying bonding slurry or epoxy. Minor cold joints can be repaired using epoxy injection, sealing, or pressure grouting. Severe cases may require jacketing, strengthening, or partial recasting. Good site practices can prevent most cold joint problems. Always ensure uninterrupted concrete supply, proper manpower, standby equipment, and continuous supervision during concreting. To conclude, cold joints may look small, but they can seriously affect structural performance and durability. Proper planning, proper execution, and proper supervision are essential for achieving strong and durable concrete structures. Thank you for watching this video. If you found this useful, please like, share, and subscribe to We Civil Engineers. And don't forget to press the bell icon for more civil engineering content.